Hello, 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 my friends. Let's continue on with this. How can you identify an oxidation reduction reaction? The oxidation number changes it's going to be two things, but you only have to check one. Okay. Where are the electrons located in a balanced oxidation half reaction? So if you have an oxidation half reaction, remember oxidation is loss of electrons. So electrons are products. What are the rules for applying oxidation numbers? Man, I'm having serious deja vu right now. 1. Elements are 0. 2. Oxygen is -2 with a one little star of peroxide. 3. Hydrogen is +1 with a one little star of except NaH. H, -1. O equals -1 in peroxide or sodium peroxide. And then rule number 4 is trust nobody. Well, trust the outside of the periodic table the most, but trust no one. Just joking. You can trust a few people. Determine the oxidation numbers. Okay, so each oxygen is -2, so combined is -4, so that's +4. It's always nice when they do this, and it's just that charge. Element standard state. Each oxygen is -2, so that's -8. Sulfur is +6 because +6 minus 8 equals the charge. So again, oxygen's -2, so this is -6. So here it's +4. Notice how sulfur's got a number of different oxidation numbers. All these together are -8. Got to end in +1. Manganese is +7. So what I do sometimes is element plus whatever I know, usually my oxygens, equals charge. Notice how a lot of times it's an element and an oxygen. So the O's you figure out because they're always -2, which is nice. For the following reactions, balance it. Write the net ionic equation. Determine the oxidation states of all species. Determine the reaction as a redox reaction. Okay, here we go. So balance it. Dun, 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 dun. 2 chlorines, 2 chlorines. There we go. Write the net ionic reaction. So notice all I'm really caring about here is my hydrogen because all these things are changing state. So ugh. So zinc plus H positive, Cl negative is going to fall out. Yields Zn plus 2 plus H2. So notice how Cl negative and Cl negative are going to cancel out there, so I cheated a bit. Write the net ionic equation. Determine if the oxidation states of all species. Okay, so here's my ox numbers. Element is 0, hydrogen is +1, +2, element is 0. Is it a redox reaction? If the redox reaction, determine what is being oxidized, what's being reduced. So zinc is becoming more positive. Zinc is ox. H positive is reduced. So notice reduction, the charge went down from 1 to 0. Okay. Now normally you've got bigger things than that to deal with, but it's okay. Like here we're going to have some ions that are going to go crazy. First thing I'm going to do, I can cancel out my nitrates. Anything else clearly aqueous? Oops, sodiums. Goodbye, goodbye, goodbye. All right, so we're going to start with, I got to balance this to begin with. 2 of those gives me 2 sodiums and 2 nitrates. That's it. Okay, so then I have to write the net ionic equation. Cobalt plus 2 plus HPO4 minus 2 yields COHPO4. Oh man, why am I writing this like I'm 4? I know it's a capital P. I know it's a capital O. All right, so that's my solid. And on this one, a lot of times precipitate reactions do not have their oxidation numbers change. This is +2. You don't have to give oxidation numbers of everything. All species, well, there we go. H is always +1. Oxygen is always -2. So +1 minus 8, so that's +7. So P has to be +5. And then this is going to be the same thing. CO equals plus 2, H equals plus 1, O equals minus 2, P equals plus 5. So that's the same. So none redox. I think that's what it told me to do if it was not redox. Yep. Get my box around there. So stay back, stay. Ooh, a combustion reaction. Combustion is always redox. So to balance this bad boy, I've got 4 H's. Throw a 2 here. 1 carbon. Okay, so I've got 2 oxygens, 4 oxygens, 2 oxygens. There we go. Carbons, a redox reaction. The net ionic. The net is the same. Redox, or oxidation numbers, ox numbers. Carbon is minus 4. H is plus 4. O is minus 2. Okay. Oh, I did the wrong thing. H is not plus 4. H is plus 1. Remember, oxidation numbers for one of them, right? So hydrogen is always plus 1. And then on the other side, I have H that is still plus. H equals plus 1. O equals negative 2. C equals, this one over here is going to be plus 4. So the things that change charge, O minus 2. No, that's not right. There's my problem. O is not minus 2 over here. Oxygen is 0 because it's an element. So oxygen change charge and carbon change charge. Okay, what else we're supposed to put in here? Determine oxidation species, determine if the redox reaction, if the reaction is reduction. It's being oxidized, so it's being reduced. So on this one, carbon's charge is going up, so carbon is oxidized, and oxygen's charge is going down, oxygen is being reduced. Oh good, we're almost done with these. Anything I can cancel out? Nothing. Okay, so let's ionize it. H positive plus SO4 negative 2. It's aqueous and a strong acid. Plus calcium plus 2 plus hydroxide, strong base, it's ionized 100%. Yield CaSO4 plus H2O. And that's a solid, so I write it together. I should have balanced this, I suppose. I think that's it. Yep. Okay. So then oxidation numbers of everything. H equals plus 1. O equals negative 2. S equals plus 6. Negative 8. I got an N to the plus 2, so it's plus 6. Calcium is plus 2. I love when they give me the charge. O equals negative 2. I already have that on there. It's not any different. And H is plus 1. I already have that one. It's not any different. And then I'm over here. I'm going to have calcium is plus 2 because it cancels the sulfate. This is sulfate. This is sulfate. So my sulfurs are going to be the same. S equals plus 6. O equals negative 2. And then hydrogen equals plus 1. No redox because the oxidation numbers are the same. All right. Complete the reaction. Determine if precipitate or gas forms, include the phase symbols. Okay, so that works out. So my only possible thought is NH4Cl. This is aqueous because NH4s are positive. Not positive, are aqueous. So solubility rules, no reaction. Now remember, NH4OH forms because it's a weak base, but other NH4s don't. They ionize. Boom, boom. So, what am I going to make? I'm going to make some barium nitrate. No, I'm sorry, barium phosphate. Check my charges. Barium is plus 2. Phosphate is minus 3. And we have to put in the states of matter. I think that's all it's really asking me to do, right? Complete the reaction. Determine if... okay, so I should eliminate the ones. You should rewrite those, but I'm just trying to give you a quick little dude there. Oh, man. My marker is too powerful. There you go. So that's all it is. Goodbye, K. Oops, goodbye, K. So that means I'm going to have S negative 2 plus. The only thing it could be attracted to is NH4 positive, but that's not going to react, right? So this is going to be a no reaction. NH4 positives are aqueous. Another. So goodbye sodium. So I have H positive plus Cl negative plus HCO3 negative. Okay, so HCO3 needs a new partner. It's not going to be chlorine. It's going to have H positive plus HCO3 negative, and I'm going to get H2O liquid plus CO2 gas, because remember, H2CO3 turns into those. This is your answer. Oh, is that it? That's it, and I'm out of here. Toodles.